Welcome to Study Loop.
Okay, so in this problem we're going to be asked to find the shear and bending moment diagrams as well as the maximum shear and maximum bending moments. Okay, so the first step to do would be to set up your free body diagram using the included forces, and then we need to find the reaction force right here, F of Cy, and to do that we'll go ahead and we'll sum up our forces. Which is going to be negative P minus P plus Cy equal to 0, which means that Cy is going to be equal to 2P. So it's fairly simple right there. And then from this we can go ahead and start to fill out our shear diagram. So we know that this first segment right here, we have internal shear. So we want to find what this is going to look like on a beam. And it's going to be counteracting our first force of P right here, this first one. So that's going to end up looking like this. It's just going to be a straight line along the length of A right there. And then once we hit our second force right here, our shear is going to increase by that factor of P. It's increasing to counteract the extra force. And then it's going to stay the same until we get to the end of the beam where the beam is fixed. And the shear is going to go to 0. Okay, so now our moment diagram is based off of our shear diagram. It's just going to be the slope. Our shear diagram determines the slope of our moment diagram. So we'll have a slope of negative P, and then we'll have a slope of negative 2P all the way till the end. So it'll be a lot steeper. Okay, so that's generally what these two diagrams are going to look like. Now we need to find the maximum for both of these. Our maximum shear is going to happen here because we're looking for the absolute maximum. And the maximum for our moment is going to happen down here on the bottom. So luckily enough for us, we know what our Vmax is going to be based off of our diagram. The absolute value is just going to be this negative 2P right here on this bottom segment. That's where our maximum is going to be. Since we're looking for the absolute value, our maximum is going to be 2P. And then for our maximum moment, we know it's occurring right here on our beam, which is our x value of 2A. So at 2A is where we're going to find our moment. So we'll cut the beam right at the end at 2A. We have our forces. We have our shear and our bending moment. Our bending moment is what we're going to be looking for. So if we set up our equation, we have 0 is equal to a negative V minus P minus P. V is equal to 2P, as we have already seen. So that's at this point right here. Okay. Now, to find our moment, we're going to be subtracting P times 2A. It's the length, the total length. And then we have another negative moment from the second P, multiplied just by the length of A, right there. And then when you go ahead and solve this, we're going to get our maximum moment is going to be equal to 3PA. And that's our answer. So our Vmax is 2P and our Mmax is 3PA.